In problem 5, we want to test whether an increase occurred in the mean hourly wage from 2001 to 2003. In 2001, according to the Department of Labor, the average wage was $14.32 per hour. Our 2003 sample of 53 production workers gave a sample mean of $13.79 and a sample standard deviation of 2.26. So this is a sigma unknown problem. I'm going to copy this information into Excel before we proceed. I've copied the sample statistics from the problem into Excel. The 2003 average wage is $13.79. The sample standard deviation is $2.26 per hour, and the sample size is 53. The sample variance is just the square of the sample standard deviation. The point estimate of the difference between the population mean, which is 13.79, and the hypothesized value for 2001, 14.32, is a negative 0.53. So there is a difference between the two wages. The difference is actually a decline. The variance of the sample mean is smaller than the estimated variance of the variable because the variance of the sample mean is the estimated variance of the variable divided by the size of the sample. The standard error of the mean, also known as the standard deviation of the sample mean, is the square root of the variance of the sample mean. The value of the test statistic is the point estimate of the difference between the population mean and its hypothesized value and the standard error. Now I'm going to copy these values into the Cengage Now problem. So the test statistic at 4 decimal places, negative 1.7073, is going to be pasted into here. The standard error of the mean to 4 decimal places, 0.3104, is going to be pasted into here. The difference, the point estimate of the difference, negative 0.53 to 2 decimal places, is pasted into here. The point estimate of the population mean, which we got right here, that's the X bar, the 2003 sample mean. Now, remember, we wanted to test whether there was an increase in the mean hourly wage from 2001 to 2003. So the alternative hypothesis is whether the mean in 2003 is greater than what it was in 2001, 14.32. So if this is the alternative hypothesis, the null hypothesis is mu is less than or equal to 14.32. Now we got to find the critical value. And since this is an upper tail test, because the alternative hypothesis is saying mu is greater than 14.32, we don't have to divide the alpha by 2. We divide it by 1 because it's a one-tailed test. And since it's a sigma unknown problem and the sample size is 53, the degrees of freedom are 52. The significance level is 1%. It's a one-tailed test, so we divide the significance level by 1. The degrees of freedom are equal to the sample size minus 1. So the t critical value is found in column 0.01 and row 52 of the t table. In column 0.01, we scroll down until we get to row 52. And since this is an upper tail test, the value that is in row 52, column 0.1 of the t-table, 2.4, that value, the critical value, is a positive 2.4. To conclude in part G, we compare the test statistic to the t critical value. In the alternative hypothesis, mu is greater than 4.32. So if the test statistic is greater than the critical value, we have evidence in support of the alternative hypothesis. That's not the case here. The test statistic is less than the critical value. So we have evidence in support of the null. So we cannot reject the null, which means we cannot say the alternative is true. Thus, we cannot conclude that the wage has increased. And then we check our work, and we should get all the green check marks correct. And we do.